All right, so in this section we're going to be discussing solving radical equations, that being square root, cube root, those are your radical ones, and then cubic equations as well. And so when you are solving radical equations especially, you want to remember to check for the extraneous values. Extraneous values are values that when you solve for x, it works out algebraically to get this x value. But when you substitute x back into the problem, it does not make the left side of the equation equal the right side of the equation. So that will happen occasionally, and those are called extraneous solutions. All right, so let's take a look at the first problem here. The first step is whatever your radical is, you need to isolate that radical. And that means we're going to need to start moving stuff away from the side of the equation that has that radical. So the first thing we're going to need to move then is going to be our 3. And then we move that by adding 3 to both sides of our equation. That will give us square root of 2x is equal to 15. We now will get rid of the square root by doing the opposite of that, and the opposite of a square root is going to be squaring both sides of our equation. And when you square the square root, that just cancels it out, leaving you with 2x. And then 15 squared is 225. And that means x is equal to 225 divided by 2. Now, if we want to check our solution, we can by taking that 225 over 2 and plugging it back in for x. If you plug it back in for x, that is going to give you square root of 2 times 225 over 2 minus 3 equals 12. And 2 times 225 over 2, the 2's will cancel out, leaving you with square root of 225. The square root of 225 is 15. And 15 minus 3 is 12. Since the left side of the equation equals the right side of the equation, x equals 225 over 2 is a valid solution. All right, so the next problem, we want to start out by isolating the square root. The 4 is outside of the square root, so therefore we need to move this to the right side of our equation. There's multiplication in between here, which means we move the 4 to the other side by dividing it. All right, so we're going to divide both sides by 4. That's going to give you square root 3x plus 6 is equal to 6. And then just like we did before, we need to get rid of that radical. So we're going to get rid of this radical by squaring both sides of our equation. All right, so square the left side, square the right side. It's going to give you 3x plus 6 is equal to 36. Now subtract 6, which will give us 30. And dividing by 3, x is equal to 10. And if you substitute 10 back into the problem, 3 times 10 is 30, and 30 plus 6 is 36. Square root of that is 6, times the 4 is 24. Okay? All right, so the next problem. This one is a cube root, and so we are going to isolate the radical, and that means we need to move the 1/2 to the other side of the equation. and we'll do that by multiplying by 2. All right, so multiplying by 2 is going to give us cube root of 5x minus 3 equals 2. Now to get rid of a cube root, we are going to cube both sides of our equation. So raising the left side to the third power and the right side to the third power. That will leave us with 5x minus 3 on the left. 2 to the third power is 8. Now add 3, which is 11. And then dividing by 5 is 11 over 5. So if we plug 11 over 5 back into the problem, 5 times 11 over 5 is 11, and 11 minus 3 is 8. Cube root of 8 is 2, and 2 times a half is 1. So that is a valid solution. All right, so the next one is a radical, but it is written as a rational exponent. You need to remember that when you have a rational exponent, the top number of the fraction represents the power, the bottom number represents the root. So this right here can be thought of as the fourth root of x plus 4. So this means the fourth root, and then raised to the first power. So really it's just the fourth root of this. Now, since we need to isolate this, we have two things that need to move to the other side. The 6 needs to move over to the other side, and the 3 needs to move to the other side of our equation. Now, there's multiplication in between here, and there is subtraction here. When you are moving multiple things to the other side of your equation, you need to move the addition and subtraction stuff first. All right, so that means we are going to add the 3 to the other side. That will give us 6, parenthesis, x plus 4 to the 1/4 power equals 12. We now need to move the 6 to the other side of the equation so that we can isolate this radical. And we move the 6 by dividing it. All right, so that's going to give us x plus 4 raised to the 1/4 power equals 2. All right, so now the next thing. We have isolated the radical. This is a fourth root, which means to get rid of this, we need to raise both sides of our equation to the 4th power. So you can think of this property right here. When you take an exponent and raise it to another exponent, you multiply those exponents together. And 1/4 times 4 is 1, which gives us x plus 4 to the 1st power, and then 2 to the 4th power is 16. All right, and then the last step is subtracting 4, which gives us 12. And if you substitute 12 back into the problem, 12 plus 4 is 16. The fourth root of 16 is 2. Because 4 2's multiplied together will give you 16. And then that 2 times the 6 is 12, and 12 minus 3 is 9, so that works out. All right, so the next problem, it's a little bit different because we have variables on both sides of our equation. This is where you really need to watch out for extraneous solutions. All right, so like before, the first thing we need to take care of is isolating the radical. Well, that has been done already. So your next step is to get rid of the radical. Well, the radical is this exponent right here. We can get rid of this by raising both sides of our equation to the second power. That does not mean square the x and square the 4. That means we need to square the x minus 4. Alright, so what that gives us then, 6 minus x squared minus 8x plus 16. Now this is a quadratic equation, which means we need to set this equal to 0. So we're going to add the x over to the other side, and we're going to subtract the 6 to the other side. Giving us this equation. Now the easiest method for solving this is to factor, which factors down to x minus 5 times x minus 2, giving us the solutions of 5 and 2. Now when you plug 5 back in here, you get 6 minus 5, which is 1. 1/2 power means square root. The square root of 1 is 1. Over here, 5 minus 4 is also 1. So that gives us 1 equals 1. That works. Now when you plug 2 in, you get 6 minus 2, which is 4. This means square root of 4, which is 2. Plug 2 in over here, you get 2 minus 4, which is negative 2. So you end up with 2 equals negative 2. That is not a valid solution, which means 2 is an extraneous solution. The only solution here, therefore, is going to be x equals 5. All right, so the next one, once again, the radical has been already isolated on the left side of the equation. So your next step is to square both sides of our equation. That will give us 2x plus 30 equals x squared plus 6x plus 9. Once again, it is quadratic because it's x squared, which means we need to set our equation equal to 0. So we're going to subtract 2x over to this side, giving us plus 4x, and subtracting 30 will give us minus 21. Now factoring will be x plus 7 times x minus 3, which means x is equal to negative 7 and positive 3. Now when we plug the negative 7 back in for x, you get 2 times negative 7, which is negative 14. Negative 14 plus 30 is 16, and the square root of that is 4. When you plug negative 7 in over here, you get negative 7 plus 3, which is negative 4. Left side does not equal the right side, so negative 7 is an extraneous solution. And when you plug 3 in, it is a valid solution. So x equals 3 is our only solution for this problem. All right, so once again here, we're going to square both sides of our equation, which will give us 2x plus 3 equals x squared. Once again, it is quadratic, so we're going to set this equation equal to 0 by subtracting 2x and then subtracting 3. We'll factor this down, which goes down to x minus 3 times x plus 1. So x is equal to 3 and -1. And when you substitute these back in, you find that -1 is an extraneous solution. So x equals 3 is our only valid solution. All right, next problem, squaring both sides of our equation will give us x plus 5 equals x squared plus 10x plus 25. Setting it equal to 0, we're going to subtract x and subtract 5. Giving us x plus 4 times x plus 5. So x is equal to -4 and -5. And when you substitute these back in, if you substitute -4 in, you get square root of 1, which is 1. And -4 over here gives you 1 as well. Plugging -5 in, you get 0 on both sides. So both of these solutions are valid solutions. All right, so the next problem here is a cubic equation. And so on the cubic equation, we need to isolate the part that's being cubed. So once again, we have a +1 and we have a times 6. And when you're solving equations, you move the addition and subtraction stuff first, and then the multiplication or division stuff. So we start out by subtracting 1. So we have this equals 48. Now we divide by 6, which is 8. And then to get rid of a cube, we do the opposite of that, which is taking a cube root of both sides. All right, so we're going to take a cube root of the left side and a cube root of the right side. All right, so that cancels on the left, leaving us with just x plus 4, and the cube root of 8 is 2. Subtracting 4 gives us x equals -2. And if you substitute -2 back in, you get -2 plus 4 is 2, and 2 cubed is 8. 8 times 6 is 48, plus 1 is 49. So that is a valid solution. All right, so the next step, or the next problem rather, has 2 radicals. All right, so this is what we're going to do for this particular equation. Same basic first step, which means we need to isolate one of the radicals. All right, so let's just say that we're going to isolate this radical first. All right, so to isolate that, we need to move everything else to the other side. So we're going to subtract this other radical to the other side. That's going to give us 9 minus the square root of 2x minus 2. Now we get rid of this radical by squaring both sides of our equation. All right, so we are going to square the left side and square the right side of our equation. All right, so squaring the left, that gives us 2x plus 7. Now, when you square the right, what that means is that we are multiplying 9 minus the square root of 2x minus 2 times 9 minus the square root of 2x minus 2. So think about foiling this out. 9 times 9 is 81. 9 times the negative square root gives you -9 square root 2x minus 2. Then you have the negative square root times 9, so that's minus 9 square root once again. Then you have negative square root times negative square root, which is positive. And when you multiply a square root times itself, you are squaring it. So squaring the square root essentially just cancels out that square root. Okay? So that leaves us with 2x minus 2. All right, so once again, what we just did is we multiplied negative square root 2x minus 2 times negative square root 2x minus 2. Negative times the negative is positive, and when you multiply something by itself, you are squaring it, and the square and the square root cancels each other out. So that leaves us with 2x minus 2, which we put right here. All right, so the next step, let's go ahead and combine some like terms here. All right, so we have 2x plus 7 equals, we have a 2x on this side, we have an 81 and a minus 2, so that's plus 79. So we have a minus 9 square root and a minus 9 square root, so that's going to be minus 18 square root 2x minus 2. So what we have done up until this point is we have now gone from having two radicals down to just one radical. Now we repeat the process. And the process says that we need to isolate the radical. All right, so we are going to isolate this. All right, so to isolate that, start moving everything over to the other side. And so if you subtract the 2x, you find out that those two things are going to cancel out altogether. All right. So now we're going to subtract 79. That will give us negative 72 equals negative 18 square root. Now we divide by negative 18, and negative 72 divided by negative 18 is 4. So 4 is equal to the radical. All right, next step is we need to square both sides of our equation, which will give us 16 equals 2x minus 2. Adding 2 will give us 2x equals 18, and dividing will give us x is equal to 9. All right, so that was a lot of algebra to get this x equals 9. Let's see if that is a valid solution by checking our answer. All right, so plugging the 9 in right here will give us 2 times 9, which is 18. 18 plus 7 is 25. This gives us the square root of 25, which is 5. All right, so plugging the 9 in right here, you get 2 times 9 is 18. 18 minus 2 is 16. Square root of that is 4. And the right side of the equation is 9, and 5 plus 4 does equal 9. Therefore, yes, 9 is a valid solution.